Okay, this part I will talk about page 33 to page 34 of the chapter notes, and it's about the common oxidizing agent, which is nitric acid and sulfuric acid. So we will talk about nitric acid first. When we use nitric acid as oxidizing agent, there will be dilute nitric acid and concentrated nitric acid, right? And for dilute nitric acid, we know that the half reaction for dilute nitric acid, we can write the ionic equation. Then what would it change to? Do you remember? It's nitrogen monoxide. Okay, and then now we will study the reaction between dilute nitric acid and copper. So another half reaction will be copper. Okay, so this is the diagram for the reaction between dilute nitric acid and copper. So these are the copper. Okay, so as we know, it will give out carbon monoxide, which is a colorless gas. But what is this? It's not a cotton. Okay, it's some reddish brown gas. Why can we find some reddish brown gas at the mouth of the test tube? Do you know which gas it's in reddish brown color? Yes, it's NO2. So what happened? Why? As we know, dilute nitric acid should be given out nitrogen monoxide, NO. But why it will turn to NO2 as the mouth of the test tube? It's because of this reaction. NO in this area. NO will react with oxygen in air and turn to nitrogen dioxide, and we balance the chemical equation. That's why the reddish brown gas will be observed at the mouth of the test tube. A very interesting experiment, and I have uploaded I have attached one of the video for you, but it's very bad skill to record that video because they didn't show these gas in the video, but actually, in fact, we can actually see the reddish brown gas as the mouth of the test tube. Okay, so this is the reaction between dilute nitric acid and copper. So what you need to do is to mark down this note and complete the half equation here. Complete the half equation here by the 4 steps that I taught you before, and write the overall chemical equation and write down the observation for this reaction. I can give you some hints. The first one is, what do you think will happen to copper? The copper will. And another one is the solution. What do you think about the change of the solution? The solution turns what color from what color? And last one, what kind of gas will be given out? And what kind of gas will be observed? At the mouth of the test tube. Okay, so another one is concentrated nitric acid. Similar. Concentrated nitric acid, it will turn to nitrogen dioxide, and it can react with the following substance. The first one react with all the metal except Pt, platinum, and gold. These two metals are too stable, so they don't have reaction with concentrated nitric acid. Even concentrated nitric acid has very strong oxidizing power, but still not strong enough to oxidize these two metals. Okay, and then they can react with metals like zinc and copper. So zinc will be turned to will be oxidized to zinc ion. Copper will be oxidized to copper 2 ion. So what you need to do is the half equation here and another half equation here, and then the overall. Same for here, half and overall equation. And then another reaction is we react with iron 2. Iron 2 will be oxidized to iron 3 ion. Same here. And what do you think about the observation? I can give you some hints. The solution should have some color change, okay? So you complete it. And number 3, it can react with non-metal, which is carbon and sulfur. So as you see here, I give you some hints. Carbon will be oxidized to carbon dioxide, and then complete the half ionic equation according to the 4 steps that I taught you before. And also sulfur will be oxidized to SO2. You can write the half ionic equation in the spaces here and give me the overall equation here. Okay, this time the half equation is needed. I need it. Okay, so please do the half ionic equation of carbon here and half equation of sulfur here. Okay, and then as if you have good memory, I wish that you still remember sulfur dioxide is a common reducing agent, and if sulfur dioxide is formed, then it may be further oxidized to sulfate ion by the excess concentrated nitric acid. So depends on the amount of nitric acid, concentrated nitric acid we add. If we add a lot, then the sulfur dioxide added may be further oxidized. But the overall chemical equation here, I just need this one, the sulfur which is oxidized to sulfur dioxide. You do not need to show me the further reaction, okay? So, and then here, this is just some notes. You can read it by yourself, and then this table you can read it. You can try to understand it by yourself, but I will also explain it. I need to explain it, okay? So the first one, magnesium, and then the right hand side is copper. So we can compare these two. Both of them, the nitric acid we are using is very dilute. For magnesium, in Form 4 we have learned that metal can react with acid to form hydrogen gas, okay? But when it comes to copper is very stable, has no reaction with the dilute acid. So when it comes to very dilute nitric acid, they will have no reaction, okay? So now what about dilute? If the nitric acid we use is dilute, then it's oxidizing agent. So it will give out brown NO2 in air. That means at the mouth of the test tube. And then inside the test tube, there will be colorless gas, which is carbon monoxide. And when it comes to copper, same reaction will be taking place because this is redox reaction. And when it comes to concentrated, then brown NO2 gas, you can see that it will be formed right above the liquid. You can see that the brown gas will be formed right above the liquid. Unlike the dilute one, it will be formed in air. That means the mouth of the test tube. But when it comes to concentrated, it will be formed directly above the liquid. This is the difference, okay? And the type of reaction are different. This one are the easy things that we have learned in Form 4. But when it comes to these two, it is redox reaction we have learned. And these two are the redox reaction we have learned. And the oxidizing agent is HNO3. The oxidizing agent is HNO3. Okay. And then another one is concentrated sulfuric acid, and it's also similar. Okay, for concentrated sulfuric acid, we have learned that concentrated sulfuric acid will be reduced to sulfur dioxide. Then you can complete the half ionic equation first by yourself. And then the first reaction, same as nitric acid, it can react with metal except Pt and gold. Okay, so again, you can do the observation here by yourself, and the overall chemical equation, the overall ionic equation here. Okay, and same as nitric acid, zinc will be oxidized to zinc ion, and copper will be oxidized to copper 2+. Okay, and same with non-metal, so I'm not going to repeat, but in the videos that I attached, they have a method to test for the sulfur dioxide, because some acid can also react with metal, but it will give out hydrogen gas. So besides using a burning spleen to test for hydrogen gas, which will give a pop sound, how can we test for sulfur dioxide? Please find this method from the attached videos and write down the answer here, and then show it to me as the assignment. Okay, another property of concentrated sulfuric acid is not relevant to the red oxidizing property, because it's only the dehydrating property, because concentrated sulfuric acid will extract all the water. That's why when it is poured onto your skin is not only oxidized, but also all the water from your skin will be extracted, will be taken away by the sulfuric acid. That's why your skin will be like burnt. Okay, so in this video I have inserted a link into Google Classroom. You can just click that link. You will see where is the carbon and where is the water. You will see some steams given out, and you will see some black solid formed in that video. Okay, so to balance the chemical equation, 12 carbon will be formed and 11 water will be formed. Okay, and this one I have done for you. And then the last one, some conclusion for the reaction of iron. Okay, for the reaction of iron can be oxidized to iron 2 or iron 3. It depends on what acid you use. When you use dilute hydrochloric acid, concentrated hydrochloric acid, dilute sulfuric acid, and very dilute nitric acid, they don't have oxidizing property, then it will be just iron will just be oxidized to iron 2+. Okay, but when it comes to some oxidizing agent, some acids with oxidizing property, then it will be oxidized to iron 3+, because it will be oxidized to iron 2+ first, but iron 2+ formed will be further oxidized to iron 3+, and those acids with oxidizing properties are concentrated sulfuric acid, and then concentrated nitric acid, and dilute nitric acid. Only these three acids has a oxidizing property, so it will oxidize iron to iron 3+ directly. Okay, for other acid, it will only be oxidized to iron 2+. Okay, and that's all. Complete page 33 and 34 and then show it to me.